Insights, solutions, and networking all come together at RSA Conference. Join a global cybersecurity community at rsaconference.com/ITSP-MAG24.
And hello, everybody. You're very welcome to a new episode of Redefining Cybersecurity here on the ITSP Magazine Podcast Network. This is Sean Martin, your host, where I get to talk about all kinds of cool things, cyber, chatting with cool people who know way more than me anyway, which is not hard to do, as they do a lot of work for the community and help organizations secure the business and help them protect the revenue that they are all trying to generate. And that's no small feat, of course. If you're listening to this, you probably have a handful of challenges that you're facing every day as a security leader. And the complexity only grows when you start to pull all the components, nuts and bolts together to make something bigger, and you end up with a supply chain that makes it all happen. Yet another angle that you get to explore and understand as a CISO and a business leader. And nobody better, I think, to have a conversation about red teaming that baby. Let's red team the supply chain. Paul McCarty, it's good to have you on the show, man.
Thanks, buddy. Thanks for having me. I appreciate it.
It's good to see you again. It's been a bit now. I think we're on opposite sides of the world now, but we got to meet in person a few years back at RSA conference. I think it was the Innovation Sandbox, and I've been watching you grow and do some cool things. And as with a number of my conversations, they're usually triggered by a post that I saw. And I think this is no different, where you put something on LinkedIn about red teaming the supply chain. I'm like, let's talk about that. Come on, Paul, let's have some fun. So it's good to see you, man. Glad you're with me.
Thanks, buddy. LinkedIn for the win, right?
Exactly. Good, better or worse. A lot of my inspiration comes from there. Nonetheless, challenges surface, and they inspire me. Yeah, I'm happy to be inspired anyway. I'll leave it at that. Before we get into what it means to red team the supply chain, maybe a few words, Paul, about some of the things you've been up to, what you're doing now, and how this fits into the big picture for you.
Cheers, mate. So my name is Paul McCarty. I'm I was a founder of a software supply chain startup called SecureStack. I've recently moved over to GitLab, so I'm 2 weeks into that role, so I'm very happy. I'm here under my own capacity, however. My time at SecureStack, and even before that, really was kind of spent understanding application environments, how complex they are. The fact that the applications that teams are building now are materially more complex than they were 2 or 3 years ago. And I think, and maybe this is what sparked your interest in that LinkedIn post, was that I think that we just haven't really kind of come to terms with that. The industry really hasn't observed the fact that, the software supply chain is different than it was, is materially different than it was just a few years ago, because we're using different stuff. I want us to talk about that.
Let's start there, because I think that's going to really set the stage. Because I can go back to when I was slinging C code, C++ code, right? So, and running NetWare, even further, kind of date myself, NetWare code, and LMs for the win. Let's talk about, because it's not just the end result app, right? And it's not just libraries and code, but we're talking about services and open source, and even the I presume even the ways in which stuff gets built, like GitHub and other things like that, all add to that complexity. How you build it, how you maintain it, all the stuff. So maybe paint that picture. I'm not doing it justice because I haven't slung code in a while, but paint that picture for us.
No, yeah, great point. So, I think that's part of the issue, is that that complexity I was talking about a second ago, in the software supply chain and the applications that we're building and deploying, the supply chain that builds those applications is more complex than I think many people realize. But when I talk about it with them, they quickly become, that makes sense. So to double click on that, I think most organizations and many people think about software supply chain and they think, the open source libraries and the frameworks, right? And there's a lot of focus inside of our industry right now on those libraries and those and making sure, attesting that those libraries and those pieces of third-party code that we're bringing in are secure. And that is important. And there's a lot of people working on that side, the SBOM, Cycle and DX, and Toto, and the Salsa, groups that are working on that. But there's a lot more to the supply chain for the applications that we're building. So if we really kind of look at it, the software engineers and the QA teams and the people that have access to the source code, they're part of the supply chain. If you take them away, well, guess what? You don't have a working application. You can't build your application. Yeah, exactly. And so and things like the runtime, right? So if you take away some of those services in AWS, like Cognito or API Gateway, if you take those away, the rest of the application can be completely functioning, but it stops working because you took that small component away. And that needs to be there to be able to build and operate these applications. So because there was kind of a lack of understanding about what it took to build these applications, I wrote a open source project in 2022 called Visualizing the Software Supply Chain. And you can find that online if you just search for Visualizing the Software Supply Chain. But the point, Sean, there was to say, hey, let's talk about it. Let's talk about each one of those stages of the software supply chain. What's in each stage? And so the way I visualized it, there's 10 stages to the software supply chain. And let's understand what each of those 10 stages are. Let's drill into each one of those. And then you can apply that visualization project to the applications that you need to figure out, that you need to identify risk in. So that was the basic idea behind that project.
Yeah, and I think I'm looking at the visualization for those 10 elements, if I'm not mistaken, where hardware is part of it, right? If you're using a hardware element that does or doesn't have the third, I forget what the acronym name is, but yeah, the trusted component, right, embedded in the hardware. Intel builds one, the TP trusted.
TPM, yeah.
TPM, anyway. So down to that level, but then up to the cloud. I think of services like banking transactions, something that allows you to take a credit card as part of your app, right? Yes, there's the library, but then there's the service on the other side running somewhere that potentially has issues, and then the cloud service that they're using that they're running in, right? So the list, so it's extremes, right? And that probably goes into infinity that I can't visualize that. So talk to me through these 10 things. I just picked a couple, which weren't, they were extreme in my description, but not extreme on the placement of the image that I'm looking at anyway.
Yeah, sure. So this is Paul's take on it. So not every application is going to have all 10 stages, right? So that's the first thing to understand. This is a guide that you can then measure your applications with. But the 10 stages, as I've described them, are the people that are interacting with the source code or that are building the application. So software engineers, QA, DevOps teams, and so on and so forth. The second stage is the kind of tools, the local developer tools that people are using. These are things like IDEs, Git, even, right? Well, if you take away Git, can you deploy an application? Can you iterate on an application? Probably can't. The next stage is the actual source code that's stored inside of something like Git, and that source code is both first party, like stuff that you've written, and then also third party code, open source libraries and whatnot. The next stage is integration. This is where a bunch of different developers or DevOps team members bring their source code together. It gets merged, go through some tests, and then becomes one unified code base. The next stage is deployment, and deployment is where you actually take that merged individual code base and then you put it somewhere. Now that somewhere might eventually be prod, but before prod, typically you have dev and staging, you might have a UAT environment or whatever, and each one of those things is a separate deployment target typically. By the way, every CI/CD pipeline, every software supply chain is a special snowflake. So take what I'm saying here as a guide that you can then apply, like I said.
Let me pause.
Next,
in between those two.
Yeah, go ahead.
In between those two, do we get the joy of containers?
Oh, absolutely. And literally the next stage is runtime, and containers are a huge part of. Yeah. Now, the interesting thing about containers, let's just double click on containers for a second. I'm pausing going through the stages, but the interesting thing about containers is containers are used at multiple stages throughout the software supply chain. So, for example, if you're a developer, you're probably running containers on your local laptop for your local version of that application as you're building it in test, right? Well, then guess what? During integration and deployment, you have containers again. And then if you're running in Kubernetes or ECS or some other container orchestration fabric, you've got them in runtime. So this one unit is actually used in multiple stages. And I think that's an important concept to think about, because you then have risks that you have to identify in those different stages. Now, I've been working on a separate document that talks about like risks to the software supply chain. And one of those is, frankly, Docker Hub, right? We all trust it. We use it in all those stages I was just saying. And yet, pretty much anybody can create a Docker Hub account, create a Docker image. If someone finds value in that, business value, technical value, they can then use it. And then now it's part of your software supply chain. Thanks for pointing that out.
Well, it was going to come up at some point. To your point, on it sits in many places. You want to keep going on?
Yeah, I'll keep going with it. Yeah, for sure. So next was runtimes. Runtime is obviously where you take that deployment's actually doing things, providing value to the business, and I think that's the important thing there. That what's running in runtime, customers are using it, or somebody is using that for a reason, right? Next is, you mentioned it earlier, hardware. Some applications have a hardware component, right? You mentioned the TPMs, but there's also other hardware components, USB dongles, right? Some of the POS systems that I'm aware of use special dongles for their licensing. If you take that away, well, the application can't run, right? Things like YubiKeys, even, you can make the argument that if you're using YubiKeys, your developers are using that to interact with their SCM provider. Without that YubiKey, well, guess what? They can't log into their SCM provider. So next is DNS, and this is kind of an interesting one. But the reality is, most of it always DNS. If it's not DNS, it's regex, right? DNS. The idea that our customers are using applications, and often those applications have, a web portal. There certainly are APIs underneath that you're not aware of that are being called. So the reason DNS is on this list is that each one of those endpoints, each one of those services this application needs to run, typically is going to have a DNS name. Most of the time nowadays it's public. 10 years ago, that wasn't the case. We'd run dev and test and staging. That would be in a private IP space with private DNS name resolution. But now, most of the time, dev, staging, and UAT are also public with prod. And that's another thing we can get into. But anyhow, next is services. Services are the third-party services that you pull in. So you can think about those as things like your payment gateway. If your payment gateway doesn't work, if you can't get to it, well, guess what? People can't buy stuff from you. So your application, it no worky. Things like identity providers.
Or if the service, the libraries and the services the payment gateway is using.
100%. Well, and at each stage across the software supply chain, there are additional dependencies, right, behind each one of those stages. So, for example, Braintree, which is owned by PayPal, there's an endpoint that they use, but it also requires an SDK, a software development kit. So, there's multiple kind of components and dependencies along the software supply chain that sometimes people don't realize how many kind of things there are there. But finally, the last stage in Paul's version of the software supply chain is the cloud. Now, the cloud is interesting because nowadays, a lot of us are using cloud services as part of the application. It's not just deployed in the cloud, right, which is one issue, but it uses services in the cloud. Things like API gateway, identity providers, Lambda,
security services.
Exactly, yeah, 100%. So those cloud components can serve multiple roles, inside of the application. So that's the 10 stages of Paul's version of the software supply chain.
I love it.
But that's coming out in my 30 years of working with applications. So I think I got it all covered.
There's a few days in there, and we talked about this briefly, very briefly before we started recording. What I've coined the workflow bill of materials, which is all of that together, not just in an app, but multiple apps, multiple clouds that achieve some business outcome. So that's onboarding a customer, to letting them buy something, to shipping that something to them, to managing the return, to keeping them as a customer back with the marketing services and their solutions and everything. And in there is business logic, right? So if any one of those points becomes offline, or if any one of those points has a lack of integrity, or if any of those points is compromised and data is exposed, to me, that's equally as important. A much bigger problem, of course. So I coined that as workflow bill of materials. Your thoughts on that? Is that still? Do you work up to that point, or do you, from a risk perspective, do you work down and say this is the most important stuff? I work down to make sure the tree now is safe versus all the stuff in the tree supports a secure workflow.
Well, the answer is yeah. I'm concerned with it, right? And it's something that I've taken into consideration in terms of visualizing the software supply chain. So, I said it a few minutes ago. These applications we're building that are more complex than they ever have been deliver business value for somebody. Otherwise, they wouldn't exist, right? So, when you're threat modeling your software supply chain, you have to take into account that business value and what are the pieces that deliver that business value to the end customer, whether those are internal customers or external customers or whatever. And I've actually come up with a framework to help threat model the software supply chain that's called VBP, Value, Behaviors, and Patterns. And the idea there is that you ascertain the value of each component of the software supply chain, as well as the application or the target as a whole. You identify behaviors that individual humans, are exhibiting inside of the software supply chain. So you developers, do they sign their Git commits? Are they using YubiKeys, things like that, right? These are behaviors at the individual level. And finally, patterns. Patterns are things that the company as a whole or departments inside of the company exhibit that can be then used to target, to attack. So those behaviors and those patterns are the things that either individuals or the organization exhibit, and the value is what is the benefit I can get out of targeting this thing. So that's VBP in a nutshell.
Oh, that's fantastic. And the first thing that comes to mind is I'll relate it to the SCADA or the ICS world, where they're built with defaults and they're used with defaults. And I can only imagine the number of things in the software supply chain that are used off the shelf as is. We plug it in, it does what it's supposed to. We take zero effort to understand how its configuration or its interaction with other stuff leaves us open. I don't know. That's my sense.
100%.
But, yeah.
Well, and 5 or 10 years ago, those systems, would have been hidden, obfuscated, right? Were they on the internet? Many of them were. Well, now, unfortunately, you've got Shodan and Census and security trails just pointing this out. And so the bad guys have visibility into the software supply chain or the supply chain, but we, the people on the good side, don't have the same visibility. So this is part of the problem, is that we haven't kept up with the tools that the bad guys are using. And that's yet another reason that we need to visualize this thing, the software supply chain, better, so we can understand how we can take advantage of those same tools.
All right. So you talked about your framework, the three pieces or the model, I should say, to understand the threat, which probably shapes how and where you target your assessments, which is what I want to get into now. So red teaming, I don't know. Can you describe red teaming? Is part of a bigger picture? You want to paint that first in terms of understanding
for sure
the exposure?
Yeah, and so I think a really important thing to state at the beginning is that red teaming has evolved very quickly, recently especially. So red teaming typically is the act of offensively attacking typically your own company's resources, but people do it in third party as well, to identify gaps in security controls, right? So typical red teaming, a lot of people think about physical penetration tests and sending a red team in there, right? Because we're drawing a connection to the military when red teams were physical teams that kicked down doors and shot bad guys, right? So red teaming now is evolving very quickly, and that's something that I've kind of been pushing for a while, which is that we need to be thinking about these more nuanced attacks inside of, say, the software supply chain. And that's what I've been hired to do at GitLab, but it's also what I've been doing in my own capacity for years. I use the VBP framework to identify, where the easy soft bits are inside of a software supply chain, and then I go and attack those things, and that's what I do, and that's part of my jam.
So it makes you tick. That's why you get up in the morning.
I like it. All right. So, and because there's not a lot of visibility, there, because there's not a lot of visibility there, you can do things that you can't do in the kind of traditional red teaming world, where there's lots of visibility, there's lots of instrumentation, right? You've got SOCs and people looking at this stuff. You don't in the software supply chain.
Yeah, and I think you mentioned SOCs. What is the analyst going to be looking for? Right? Are they watching app logs? I don't know.
100%.
Yeah. So talk to me about how you set up a program then. Well, let's assume we're doesn't have to be regulated, but I'm just thinking of a bank that does stuff for a healthcare organization that does stuff with important data. And we want the transactions are also important in many cases. So how you're building something for, let's say, an end user, you really want to make sure that thing's solid. How do you build a program for that?
Yeah, really good question. So red teaming is part of an offensive security strategy, an overall offensive security strategy, right? And so traditionally we've had things like penetration testing and bug bounty as part of that kind of overall strategy. So I would say that typically you'd want red teaming to be part of a group of roles that have a bug bounty program as well as penetration testing. And that's important to me because one of the best things you can look at as a red teamer, as an internal red teamer specifically, is your bug bounty issues coming in, right? These are people out there in the field, looking for stuff, and you can leverage that, internally to identify. So these are, you're leveraging the crowd, as it were, to bring data to you to then help you do that VDP and find these areas. But back to your question about how you set up a program, I think having a history as an organization of penetration testing and bug bounty are important, right? Because then a red team has a foundation to build on top of. And I think that
meaning you don't start with a red team, you have to have some foundation first.
Yeah, I mean, I think typically you do. I don't think you have to. I don't want to speak in absolutes. Okay. I don't think you absolutely have to. I can think of a few kind of SaaS companies that have red teams that maybe haven't had that traditional historical kind of pen testing and bug bounty background, but I think it helps, right? It helps because it sets a foundation. But assuming that you have those things in place, you can take findings from penetration tests or issues coming in to a vibrant bug bounty program. And by the way, you have to make your bug bounty program vibrant, which means that you have to pay enough to encourage the best hackers to be finding issues. But you can take findings from your penetration tests or your bug bounty.
You want to set the scope properly so you actually get meaningful stuff too.
100%.
Don't be scared and limit to the stuff you probably could have found yourself anyway.
Yeah, 100%. If you if you limit the scope on that. So here's the thing is, you limiting the scope, guess what? You're not limiting the scope for the bad guys. Right? They don't care that you said, hey, GraphQL is not in scope. They don't care about that. They're attacking your GraphQL, right? So if you want to be, if you want to have a vibrant, successful, functioning bug bounty program, you need to have, pretty much everything in scope. But anyhow, aside, back to your question, taking those findings from those other kind of traditional offensive security practices and then using them to build red team operations on. Now, I said at the start of this question that red teaming has evolved. I think the other thing is that traditional red teaming was very operation specific. You started planning for it. You built out the kind of early stuff, the pre-production, as it were, and then you.
That's kind of inferred by my use of the word program. Right.
Yes, exactly. Yeah. Well, and then you find people internally, assuming again that this is kind of an internal red team. You find people internally that are going to be your insiders, and leveraging them, then building the operation, and finally pushing play on the operation, and that's a relatively short-lived thing. And then at the end of it, you bring your findings back to the organization. You burn all of your red team collateral, right? And you start preparing for the next one, right? And hopefully in the meantime, engineering departments and DevOps teams are taking the finding of that red team engagement operation and creating mitigations and building a more powerful, resilient infrastructure to deal with this. Here's the thing. So that's not how the bad guys work, right? And the bad guys are there's a constant fabric of attacks that are happening to organizations. And your red team needs to kind of evolve to be like that, right? Because ultimately the red team is pretending to be adversaries. And you're trying to it's a race, right? You're trying to get to a finding before the bad guys get to a finding or until they can leverage that. So one of the things I've been advocating for a long time is what's called continuous red teaming. And so this is a slightly different model. This is a model where you're building many kind of continuous overlapping functions that run for a long period of time. You're not necessarily burning the collateral at the end of that operation because you're using that for other things that you're laying on top of that. And this is particularly important if you want to red team the software supply chain, because you and I talked about the fact there's 10 stages there. There's a lot of scope. There's a lot of attack surface there. If you're doing one thing, you're missing a whole bunch of other things. So you want to be able to build on top of a layered approach, defense in depth, attack in depth, right? So that's
connecting them all. Connecting them all.
100%.
So the diagram I was looking at is linear, and but clearly it's partially a build process, partially stacked elements, partially a process, right, that circles. And it could be linear as well. But I guess the point is things will overlap. They'll connect the hardware and the software, or I don't know, I'm making stuff up here, but anyway, things will connect. The combination of those two create new things to explore. The unexpected removal of one of those things creates new things to explore. So I love this idea about continuous, and I don't know, I suspect you have a framework or something to to help with guide some of that.
Yeah, indeed. I'm working on a set of, I wouldn't necessarily call it a framework, but it's more a set of playbooks that you can use. Now here's the other thing. Traditional red teaming usually has a very specific objective in mind. Like, we're going to gain access to this particular application. We're going to use these 2 or 3 methods to try to gain access to this specific service. And when we're done, we're going to present our findings, all that good stuff, right? Now, the thing with continuous red teaming is that you don't necessarily know exactly what the objective is, because to your point, where these things interlap and connect, you're pivoting within the red team, the continuous red team operation. So as an example, let's just say that, you have been tasked with perhaps, finding whether or not a new set of cloud applications are secure, right? So one part of that continuous red teaming function might be, attacking the software engineers and the software libraries, the third-party libraries that are being used inside of that. A good example is maybe like a JavaScript runtime, right? There's a bunch of new JavaScript runtimes that exist out there. Maybe because they're new, maybe part of your continuous red team operation is going to be attacking those. But at the same time, you need to see how that actually works when it's running in Azure or AWS, right? So there's a feedback loop that's happening inside of continuous red teaming that doesn't necessarily happen in a very more narrowly scoped kind of traditional red team operation. So 100%, you're right. It's like, how do those things connect? You don't necessarily know until you get into it, and you've got 2 or 3 things going, and you think, oh, now this AWS component comes in. Let me add something to the mix there too as well.
So I'm wondering, this is the view from, I'm a risk manager. I have a security team. I'm going to put this hopefully continuous program in place. That's one slice of it. You mentioned in a traditional, it's one slice and then findings at the end, and then hopefully by the time you come back around, the things happen. But the business doesn't change either, though. Or I'm sorry, the business is changing all the time as well. So the continuous piece seems like a good idea. But how I can visualize the red teaming process. How does the business visualize the value part of that related to risk? And then we'll go into how the heck do you handle the the response piece on the other side. But let's start with the business piece. We have the best red teamer and the best everything, but gosh darn it, the business just doesn't understand anyway.
Yeah, well, okay, so at the same time, in parallel, you've got this maybe continuous red teaming set of processes going, right? You also have a relationship between the business and their developers, right? The software engineers, right? So basically, the business is always looking for new revenue generating. You talked about earlier at the top of the program, we're all here to make revenue, right? The business is interested in creating new revenue and new revenue streams. And so they're working with development teams to build new features and new functions inside of their product to be able to create that new revenue, right? So while you've got all your red teaming and all your other offensive stuff going on, you've got this relationship that's highly iterative where the business is constantly asking development teams to deliver new stuff. And they're incentivizing speed and delivery of features above everything else. It's incentivized above security by 10 miles, right? Like, it's features and how quickly you can deliver them. And so there have been certain kind of interesting changes in the way that we build applications over the last just 2 years, like literally a very short period of time, based on this highly iterative thing. So for example, many teams are moving towards mono repos. The idea here is where you put a bunch of different sub repos. So you'll have like some JavaScript and some Python and some Go all in one big repository. The idea here is that you want to create a more kind of tightly coupled relationship between these things. It's kind of anti-pattern to microservices. These mono repos have become very popular. There's a lot of talk about monoliths being the right model inside of software development for certain kind of web application centric things. So if you have a monolith, you've got mono repos.
Is it like a platform component in one big bubble? That's what I'm visualizing.
Yeah. 100%. Yeah. I mean, so like, in the early 2000s, when we were deploying things like LifeRay and other kind of monolithic web, back then, and they were all based in Java, right? This everything, whether it's bell bottoms or, whatever, like everything comes back full circle, right? And now we have the idea of monoliths are back. We even have certain development teams advocating for not obfuscating and minifying their JavaScript, right? These are basic functions that we use as part of Webpack and other processes to make it harder to attack JavaScript, which runs, unfortunately, in a browser. So everybody, the attack surface is not a browser. But anyhow, you have all these things happening because of this relationship between the business and the development teams, always looking for faster development. And so the development teams are incentivized and encouraged to do these things, right? Well, the problem is mono repos and a lot of these other kind of new changes in some of these new JavaScript engines, runtime engines, have functions or features that make them easier to attack, right? A monorepo, because it's got a bunch of different applications inside of it, aren't necessarily getting the same security scanning that they would if they were separate repositories. That's one of the biggest things I've noticed with monorepos is that you'll have portions of these things that are orphaned, and so they're not getting scanned the same way. And so you have more opportunity for things to sneak in. So that relationship.
And we no longer use that bit, but it's still in the bundle.
100%.
And no longer getting updated.
Of course.
Boy. So let's talk about. I know we had a few minutes here, so we're well into the chat. I'm not going to cut it short purposely, but I want to make sure I get to the response end of this. So you talked about having relationship with the business and the engineers to, we'll just say, to design and build with security in mind. We're all human, including engineers. Sorry, engineers. They make mistakes. Things happen.
They do.
Maybe not them, third-party component, third-party server, whatever happens. And there we go. The feedback loop needs to complete there. What changes do we see on that end? Because with complexity it comes with, well, who owns, right? Did we license that? Did we pay for it? Is it for open source? Who owns that piece? Who's building it? Who's developing it? Who's building it? Who's hubbing it? Right? All the points. How does that get handled with such big scope and complexity? Very carefully.
Well, developers, we would hope, but the problem is that we're moving fast. Going back to that last point, we're moving fast, and we're human, to your point. And when you're moving fast, things creep in, right? Bad things creep in. So first and foremost, software engineers deliver software engineering. They're not security, specialists. And for us to expect them to both be able to deliver iteratively quickly and to do it in a secure way, those two things are at loggerheads, right? Now, can you use this whole shift left movement, trying to encourage developers to do things in a more secure way and secure by design? That's all good and well, and there are things that you can do. But the reality still is that there's a challenge there where those two things are, they're butting up against each other, right? So for example, in a red teaming operation, in fact, I've even done a training on how to attack software engineers as part of the software supply chain. I love attacking software engineers. It's like one of my favorite things because there's just not a lot of visibility going on there. There's just so many different things. There's so many moving parts there. The way that software engineers interact with the source code repositories and source code management tools, there's just a lot of opportunity there for attack. And it doesn't seem like many other organizations are doing that. And certainly red teams traditionally that hasn't been in scope for red teams. And that's part of what I bring is that for me, that's 100% in scope for sure.
That's the SESE village at DEF CON. Social engineering, software engineer village.
Well, yeah, I mean, it's not just software. It's not just social engineering either. It's just the fact that I think many engineers don't realize how many layers of dependency are inside of the things they use every day. Like their library that they're using, it hasn't changed for maybe 4 or 5 years, right? But it's calling other scripts, pre and post install scripts and other dependencies that can change. It's calling things from CDNs. Well, guess what? Why don't you attack the CDN, right? There's a lot of places here for us as red teamers to probe and test the way we have it in the past. So game on. So let me ask you this, and it's a question that I ask almost every guest, depending on the conversation, of course. But you touched on a little bit that there's the shift left movement. We could hope the engineers build better, secure by design, all that stuff. It's a valiant effort. I think it moves the needle to some degree, better than not doing it. But going further left, back to the business, and I want your perspective based on the red teaming results. So not just feeding the engineers, we need to update this library, or we need to change the way we call it, or whatever it is we have to do. Move over further and
to the business, we say, well, let me take one step back. We continue to see this JavaScript come up over and over and over. So the advice to the engineering team is let's evaluate that. Maybe there's a different way to use the script, pick a different script, whatever it is, different library. Move that further. Is there a way to guide the business to say, what are you trying to accomplish? And can we reevaluate the way we're accomplishing it to where we don't even have to worry about that thing that keeps biting us? And the example I give in the broader security program world is just patch management, which is kind of related. But if we continue to patch this legacy system that's taking 25% of our team's time, is there another way to build that program to not use that system that's causing us to spend so much money and time patching it? So that's what I'm thinking about, but more now from your perspective on the red team results and guiding business.
Yeah, well, okay. So one angle to come at this question is to say, I think many businesses think that we can address this in the CI/CD pipelines, right? And basically this idea that everything comes together, there's a gate, there's a common singular kind of central gate, which all this stuff goes through, and we can shift up until that point and do everything there. And we many of the kind of vendors in the space emphasize this point, but the reality is that for many organizations, the maturity of their software development lifecycle isn't. I have a saying that it's almost software development maturity is almost always overestimated significantly, and we're assuming that every team in every scenario always uses CI/CD, so that gate is always works. But that's not the case. That's not reality. For the last 6 or 7 years, our focus, when I had my own business, was helping startups and scale-ups. And the reality is that, maybe they might have a functioning CI/CD in this one application, this one place, but it didn't work for dev, right? And it didn't work for all these other. So this idea that we can tackle it in one place isn't the reality, or we have to wait for the maturity, Sean, to catch up, right? The business is hearing that, oh yeah, we've got this thing in the CI/CD pipeline, and that's great, and it has to be there, absolutely needs to be there. But we also need to push a little bit further left. I feel like, if our goal was to find the end of the Amazon, we didn't shift all the way left, right? We stopped about halfway and we called ourselves success. We need to push past that, and the business needs to say to engineers that, hey, there are things that you can do as part of your daily interaction with source code and the dependencies that we're using that are building our applications that you can do individually on your laptop that provides significant benefit. And the metaphor that I've used for many years is that if you can stop the poison being poured into the water supply, it's a lot easier to stop that single engineer who might accidentally be pouring that poison into the water supply than to try to take the poison out of the water supply, which is what happens when it's already in SCM and it's already starts going down a pipeline.
Yeah, I love that analogy. And I was also picturing the Truman Show, right? Where you can hit so many walls so many times. It's the same in reality, unless you go outside and see where things are really being controlled from. I don't know if people watch that movie and know what I'm talking about there, but it's there's dev reality and then there's business reality, right? And you can push 100%. As far left as you want in that one reality, but you can only go so far left. I think that's why I think you have to jump out of the wall or find a way through the wall to really make widespread impact, especially when we're talking about something as broad as this. Because we didn't even talk about business partners and stuff. We're talking software supply chain, but forget about third-party supply chain as well. You tack that onto the mix.
Well, that's the cloud providers and their security responsibility. Unfortunately, we didn't get a chance to talk about that, but here we are.
I'll say a few things there if you want.
Well, I think when I was dealing with those startups and those scale ups, they universally thought that if they were using Azure or AWS, that everything that they used there was secure by design, right? And just to be clear, if you do things right, if you follow best practices, AWS and Azure and all the other cloud providers, well, maybe not all of them, but the good ones, absolutely are more secure than what you can build in a data center yourself, because you don't have the time and the subject matter expertise to do it yourself. But this assumption by teams that simply because they use these services inside the cloud that they're secure and they don't have to do anything is ridiculous, because even the cloud providers themselves will tell you, no, you own that part of that, right? Like there's this shared responsibility model, but we just kind of universally ignore that. And because these applications we're building talk to so many of these cloud services, most of which are public endpoints, Cognito, API Gateway, Lambda, all these things, they're all public endpoints. That's just a lot more attack surface, that we're building into our applications now than we had even 5 years ago. So yeah, that relationship between the cloud providers, that's always been a challenge. They do a great job of securing their internal stuff, but the teams expect a lot more. And some assumptions being made there.
Yeah, and I mean, to my point earlier, it's the holy grail for me that security can change the business to be more secure, not just secure the business they built. So I realize it's a lofty goal, but and the reality is they're only going to be in business if they can build something that generates value that they can sell and make money to pay their employees and shareholders and whatnot. 100%. And to do that sometimes means moving fast and being first to market with something cool that nobody else has done. And sometimes that requires using certain things, using technologies and services, AI, cloud, whatever it is. It's a constant shuffle. I think the main point for me is that if you don't recognize that and you just move forward, that's one thing. If you recognize it, understand it, see the risk, blindly accept it, that's another. If you understand the risk and try to mitigate it, that's even better. And then if you can figure out a way to actually do it better from the beginning, that's where I'd love to see things go. And speaking of going, I'm not saying goodbye yet. I'm giving you two minutes here. You're going to be going to a couple places. What is it? B-Sides and a Brisbane Security, BrizSec, if I'm not mistaken. Doing a couple presentations. You want to take a minute to share what you're doing at both of those places?
Yeah, thanks. So I've booked 3 already, and I've applied to some stuff in the US too as well. So we'll see if that happens as well. But yeah, I'll be doing Crikey in March. I'm doing a 4-hour training session, a workshop on red teaming the software supply chain. I'm doing all day an 8-hour training at B-Sides Adelaide. And then I'm also having a talk, just a talk at BrizSec in Brisbane. I think that's in April, if I'm not mistaken, but I don't have it in front of me right now. But yeah, those 3 things are already booked, and hopefully there will be more.
Nice one. Well, I'll include, I have those links from you. Thanks for sharing those. I'll put those in the show notes so people hopefully can connect with you. If they're anything like me and enjoyed even just a sliver of this, I'd want to connect with you in person again. I certainly will at some point, hopefully in the near future, down under or up here somewhere in North America, if we can make it out. We're in Europe. If we have to meet somewhere mutually exclusive of our home areas, home turf, we can certainly do that too. But it's a pleasure seeing you again, Paul. Pleasure chatting with you. My final question as we wrap, based on today's conversation, what's the one thing whoever the we is, you can define, that we need to do to redefine cybersecurity?
To redefine cybersecurity, well, understand the true scope of what's, what cybersecurity applies to, right? Application security and cloud security and the things we've talked about today are things that I think many InfoSec teams aren't necessarily thinking about a lot, right? They've got a traditional set of things they're doing, and maybe think broader about what are the actual attack surfaces there, and maybe they can come and take a look at some of the things that I've written and expand that scope.
Perfect. Well, thanks so much, Paul. keep posting, keep presenting, keep workshopping, and please keep coming back for more with me here. You're welcome anytime, of course. And for everybody listening, I'll be sure to include a LinkedIn post just because we referenced that, some of the stuff that Paul's going to be doing at some events over the next month or two, and any other links that he thinks would be useful to help people think differently and more broadly about cybersecurity as we all work together to redefine cybersecurity. Thanks, everybody. Be sure to subscribe, share with your friends and enemies, and follow Paul. Paul, we'll see you later, my friend.
Thanks, buddy. Cheers, mate.
Insights, solutions, and networking all come together at RSA Conference. Join a global cybersecurity community at rsaconference.com/ITSP Mag 24.